Hi, so in this video we'll learn about chapter 6, circular motion. So I'm going to do a little bit of introduction and you can try to do the tutorial question afterwards. No? Okay, uniform circular motion. In this chapter you need to know two main subtopics. One is the circular motion itself. Okay, another one is centripetal force. Okay, so most of the question in terms of calculation comes from this subtopic. Okay, so circular motion is basically any object that undergoes a circular motion. No? Okay, and then in terms of few quantities, I would like to introduce a little bit. So this chapter you might have to use quite a few times on about omega, about theta. So you see some of the quantity use that symbols. So previously in linear motion you have S, V and A. Okay, now in terms of if you have an object that moves in circular motion, this is point A and point B. When I say the linear displacement S, it is actually represent the distance travel from A to B. Like that. Let's say they travel for 2 meters. So here is 2 meters. So this is your S. Okay. But in terms of theta, it is actually the angle from between A and B, the radial distance. So let's say if that's the center, so the theta would be this one. Normally we use a symbol radian. Okay. And then previously if you have V velocity for linear velocity, it will be in that direction and you can calculate V equals to S over T, right? But now it would be theta over time. So you have the unit of radian per second and this one will be radian per second square. Okay, the relation between S and theta would be S equals to R theta, V equals to R omega, and A is equals to R alpha. Okay, so this is just a little bit of introduction. Okay, before we go further, what does it mean by uniform circular motion? If you go through your lecture notes, okay, circular motion is motion in a circular path, okay, and for uniform means the motion of the body traveling in circular path at a constant speed. Okay, so you can say that this one is actually an object traveling and in circular motion at a constant speed. Okay, so an object that is traveling in uniform circular motion will have a constant speed, but it will have an acceleration. So this is the only case where you have constant speed with acceleration. Okay, so the acceleration actually comes from the change in direction of velocity. So example over here, you have a velocity in that direction, okay, and as it goes further, let's move some more. Now the V is changing in direction. The speed is the same, so that's why you have constant speed, but here you have a change in direction, therefore it will produce an acceleration because there's a change in direction of velocity. So acceleration will happen when you have a change in direction or change in magnitude. Okay, that was for the first subtopic. The next subtopic is about centripetal force. Okay, so what is centripetal force? Centripetal force is actually force acts on the body moving in circular paths and directed towards center. So the centripetal force is actually not a type of force. I mean, it's more like a net force. So that's why I represent this one with a summation of the symbol of summation over here. So if you guys remember, in chapter 4 we have summation of fx and then summation of fy. This is basically sum of force in x component, sum of force in y component. So here centripetal force is actually sum of force that towards the center. Okay, so and in this case it will replace the fx or fy. I will show you example after this, maybe you can understand it better. Okay, it will be towards the center. The formula similar with the summation of F equals to MA, but now since this one is centripetal C, I will put A with the centripetal acceleration as well. Okay, so what does it mean by AC? It's actually acceleration of an object moving in circular paths and whose magnitude is equal to the square of the speed divided by the radius. So speed. Okay, that one is just the definition. So it is actually acceleration of an object moving in circular path. So like I told you before, if you have an object moving in circular path, even though you have a constant speed, you will still have the acceleration. And this acceleration here is the centripetal acceleration. It will be always directed towards the center, like in this example. And the formula would be V squared over R, this one. And this one also another formula, AC equals to R squared over omega. But most of the time you're going to use this one. Okay, so if you remember previously, summation of FC equals to MAC. I can substitute AC with V squared over R, so you end up with something like this. Okay, there's a few types of uniform circular motion that you guys need to know. Okay, so basically you can divide into two types. One is horizontal motion, another one is vertical motion. Okay, so for horizontal motion, you will have a combination of summation of F. It used to be Fx and Fc, right? Sorry, Fx and Fy. For horizontal motion, the Fx now will have Fc. On the other hand, for this one, it used to be Fx and Fy. So the Y will be your centripetal force. The centripetal force will be in vertical plane. Okay, so for each of these, you have few more examples that you guys need to know. Like over here. Okay. You have a horizontal circular motion. You have a flat curve. You have a conical pendulum. Okay, all these three is basically your horizontal circular motion. I just divide this. And for vertical, you have Ferris wheel and vertical circle. Okay. Oops. Okay, example for circular motion in horizontal. So I'm gonna go through each one of these now. So this is some of the key important things that you guys need to know. So this question might be slightly different in terms of situation, but you can imagine it will be something similar to this. Okay, so this is the example, the diagram that you can see. This one you have maybe an object attached to end of a string, and then you start to move in circular motion, and you will have a tension in that direction. Example lah. And then over here we have a car that is moving circular motion as well in a flat surface. So this one is the top view, and then we have a conical pendulum here that move in this direction. This is a Ferris wheel. Okay, so you guys might need to know what is Ferris wheel, what is merry-go-round, and what is roller coaster. Obviously everyone knows, right? And this is an example of vertical circle. Doesn't make sense, but yeah. Okay, so for this one example, if you get this kind of question for circular motion, the first thing that you guys need to do is that you have to draw the free body diagram. So for this session, I'm just going to show you the free body diagram, and then maybe you can try to apply it in terms of solving the problem. So in this case, you have this is your body, right? So you will have tension and weight. Okay, so in real world, you will still have a slight angle. So you, unless the speed is really fast, you wouldn't get a straight line like this lah, right? Anyway, let's say this is an ideal situation where you get the tension in that particular direction, horizontal direction. So once you draw this, you need to identify the direction of acceleration. So you only have the centripetal acceleration here, and it will be directed toward the center of the circle. Okay, another key thing that you guys need to know is you guys need to understand where is your R. Okay, R is basically radius of your circular motion. Okay, so the path will look something like this. So the R will be from the center towards the object over there. So that is your R. And then if I want to write my summation of FC, okay, so the acceleration is in X component, right? So the only force acting on the X component will be the tension. So it will be tension equals to MAC. And most of the time you might want to change AC to V squared over R. So you have mv squared over R. Okay, and then you can try to solve lah. If they give you all the details, you can solve. The V here represent the speed of its moving in circular motion. Okay, here is the example of flat curve. If I have a side view, then maybe this is my car. Okay, and maybe it's moving in this path. Oops. Okay, if it moving in this path, then I will expect to have, let's say I draw the free body diagram over here. I expect to have the weight, okay, normal in that direction. Okay, and then I need to have something that is pulling towards the center. So in this case, the force, the type of force that is pulling it towards center would be the friction. Okay. Excuse me. Okay. So to avoid any confusion, I just didn't write whether this one is static or kinetic. I just leave it like that. F. Okay. So a friction, we try to pull the car towards the center. So without any friction, let's say if you have a set of tires that is almost, how do I say it? Okay, let's say if the surface of the road is very slippery, then I don't have any friction, or I have less friction, so my car will not be able to do the circular motion, so it will start to move straight line. Okay, so this is the important things lah. Friction that is trying to pull the object towards the center, and it will be directed in this direction lah. So if it is over here, it will be directed in that direction. If it is over here, the friction will try to pull in that direction. Okay, anyway, summation of FC equals to MEC. Again, you have force of friction F, and I can replace this one as mv squared over R. Okay, so in this case, since this one is a friction, I can maybe write a little bit more. Mu n is equals to mv squared over R. Okay, and in terms of y component, it will be equals to 0 because we don't have any acceleration in y component. Okay, so AC in that direction. So I can write this one as n minus weight equals to 0. So n is equals to weight in this example. So it will be mu mg equals to mv squared over r. So I can cancel out the mass over there. I will get v equals to mu gr take the square root. Okay, so here you can see that the mass doesn't really matter. The one that matters is your mu. Mu will affect your velocity there. Okay, anyway, the next one will be conical pendulum. So conical pendulum, you really have to draw the free body diagram correctly. So example over here, I will have my tension will be in that direction along the rope, inside the rope. The weight will be in that direction. Okay, so if I try to resolve, I will have dx in that direction and dy in that direction. Okay, so the theta there represent this theta. So zigzag, right? Okay. And then you have to be careful a little bit about this theta lah. You have to read the question carefully. Sometimes they say that the theta will be the angle from the horizontal plane towards the string. This one they will call it the angle between the string and the vertical line. Or they will give you a diagram like that. Huh? Okay, now if I want to indicate the AC will be in this direction, it will be towards the center. Okay, so this is your circular path, right? You can imagine it to be like this. This is the center. So I can write my let me see, and summation of Fy equals to 0. So Fy you have, in this case, you have dy minus weight, which is equals to 0. On the other hand, you have dx equals to mv squared over r. So sometimes some students they love to memorize things but for me you can always try to draw and to solve it manually. Okay, like this okay, so this one you can open up Tx equals to T sine theta, sorry, yeah, T sine theta equals to mv squared over r, and Ty is equals to T cos theta minus or equals to mg. So I can try to do a little bit of mathematics over here. Okay, you know that the sine of a cos will be equals to tangent. So I can, if I do 1 divided by 2, I have T sine theta divided by T cos theta. I have mv squared over r divided by mg. So sine over cos, that one is equals to tangent theta. So this one, tangent theta equals to v squared over r divided by the gravity there, so it will be g over here. Okay, just double check whether this one is correct. G is up here, so okay, correct. So then I can rearrange, so v is equals to rg tangent theta. Okay, this one, as long as your theta is over here, then it should be okay. You can use this one. Okay, again, this is one ways of solving it. Anyway, if you get the question, then you will understand it better. Okay, Ferris wheel. Okay, Ferris wheel. If I want to draw the free body diagram, let's say normally the question will ask you at two positions, at the top or at the bottom. Okay, so you notice before this is about horizontal plane circular motion. So your acceleration, AC, centripetal acceleration, will be in x component. So this FC would be in x component over here, like this one, right? FC is in x component as well, but since the next one would be the y circular motion in y component, so you will expect it will be in centripetal in y component Fy equals to MEC. So we didn't write this one as y, instead we write this one as C. Okay, so at the top over here, you can see that I have a normal force. So you can imagine, normally the question will ask you what happened to that person that is sitting on the Ferris wheel. So you have a normal force and you have a weight. Over here, you still have the normal force and you still have the weight as well. So the free body diagram is similar for both. The only difference here will be your direction of acceleration. Okay, so at the top there, the acceleration will be pointing downwards towards the center kan. At the bottom here, the acceleration will be pointing upwards. So the difference comes when you try to substitute inside here this equation. So like I told you before, will follows the direction of acceleration, weight minus the opposite direction, and equals to mv squared over r. Okay, so in this case it will be n minus weight equals to mv squared over r. Okay, this one vertical circle, I think you have a similar free body diagram, so I'm not going to do it. Okay, another example would be if you put a string and you attach to the object, again instead of normal, then you will have a tension. Okay, anyway, I think that's it for the introduction of this topic.